Okay, so three people, X, Y, and Z, independently solve a problem. They each have a different probability of success. And the question is asking, well, what is the probability that X gets it right, Y gets it right, but Z does not get it right? So we have different probabilities of success. So the X we're given is 1/4, the Y is 1/2, and the Z is 5/8. Alright, so since these are independent, right, these are independent probabilities, then you can multiply them to find, well, if X gets it right, that's 1/4. So 1/4 times if Y gets it right, that's 1/2. And then if Z gets it wrong, right, so we don't want Zelda to get it right. Zelda's probability of success, these are of percentage success. So if you want Zelda to fail, that would have to be the opposite of 5/8. So that would have to be 3/8, right? So it would have to be 1 minus this. So whatever remaining amount to get to 1. So this is really what we're looking for. So 1 times 1 times 3 is 3. 4 times 2 is 8. 8 times 8 is 64. So the probability is 3/64, and that's answer E. So the concept here is independent probabilities. So in independent probabilities, you can multiply them together. So we have X, Y, and Z. The success rate is basically given as 1/4, 1/2, and 5/8. So this 5/8 is success, but if the failure rate, it would be 3/8. So that's the failure rate. So what you want to do is combine the success of this, the success of this, and then the failure of this. So what's the probability of getting this exactly, and this exactly? That's basically multiplying the independent probabilities for X, Y, and not Z. So multiplying these three gets you the answer. So as a recap, we have a word problem. The word problem tells us that there's individual probabilities of success, and they all act independently of each other. If they act independently of each other, that means you can multiply them, multiply the probabilities of success or failure. And if there's a particular sequence, meaning you want success, success, failure, then you just simply multiply the probability for success, the probability for success, and the probability for failure for each of these three, just like we did here. And it turns out the probability is 3/64. Choice E.